Hello students, today we start with the chapter on functions. In our today's session, we'll be knowing about mapping and its types. First of all, we'll be knowing the meaning of this term mapping, and then we'll be knowing the different types of mapping that exist. Okay, so without any further delay, let us start with our today's session. First of all, the meaning of the term mapping. A mapping is a process used to connect the members or elements of one set called the domain. That means there will be one set which will be having some members, and that set will be named as the domain set. The independent values. Now the independent values and the dependent values, I'll be coming to this part a little later. For the moment, I'm leaving this part. And mapping is that process which will be connecting the members of this domain set to the elements or members of the other set called the range set. So there will be a total of two sets. The first one will be named domain and the second one will be named range, and both will be having some members or elements. And through the process of mapping, we will be connecting the members of the domain set to the members of the range set. Okay, so this is just the definition of the process mapping. In case you are not clear with this process, don't worry. We will be taking up different types of mapping and you will be seeing concrete examples, so it will be very clear to you. Okay, so we come to the types of mapping. There are four types of mapping. The first one is the one-to-one mapping. We are having two sets. The first one is the domain set, second one is the range set, and both are having some members. And the mapping process is this one. Y equals x plus 2. What is y and what is x? The members of the domain set are referred to by this variable x, and the members of the range set, they are referred to by the variable y. So, and this y equals x plus 2 is a linear equation, and we have graphed linear equations. We have studied about linear equations in our lower classes. Why is it called a linear equation? Because the power of x is 1 over here. And we know the graph of this will be a straight line. And how do we graph linear equations? We first of all construct a table which contains two rows. The first row contains the x values. The second row contains the y values. And what all x values do we take? We take arbitrary x values, whatever comes to our minds. Whatever comes to our mind, we just take those values of x. I have taken 5 values of x. You can take 10 values of x. You can take any number over here. I have taken negative number. I have taken positive number. I have taken 0. You can take fractions. You can take rational numbers. You can take irrational numbers. So you can take any real number for the member of this domain set. Okay? X can be any real number. And what is the process of connecting the two sets? Whatever is the value of x, you add to it plus 2. And the addition result is the value of y, which is a member of the range set, which becomes a member of the range set. Hence, the range set members are the dependent values. They are dependent on the members of the domain set. Okay? The domain set members are independent values and the range set members are dependent values. And over here, how are they dependent on one another? Whatever is the x value or whatever member of the domain set we take, we add to it plus 2, and the result that we get is a member of the range set, and that value that we had taken from the domain set gets connected to that value of the range set, that member of the range set. this is the process, or this is the mapping. And over here we are seeing for every member of the domain set, we are having one and only one member of the range set. Hence, the name one-to-one mapping. The first one refers to the members of the domain set, and the second one refers to the members of the range set. For one value of x, you have only a single value of y. One value of y. Hence the name one-to-one mapping. And over here, you see you are having only positive numbers and 0 as the members of this range set. But it is not that this range set cannot have any negative numbers. If you take the x value as negative 10, you can take any value, any real number value, and make it a member of this domain set. So we can take negative 10 to be a member of this domain set, which will be the value of x. To that, if we add 2, the corresponding y value will be negative 8. So negative 8 will be a member of this range set. So it is not that you cannot have any negative number in this range set. You can have negative numbers, you can have fractions, you can have rational numbers, you can have irrational numbers. So every real number is possible in this range set as well. But it is not that you can have every real number in this domain set and every real number in this range set always. In this case, one-to-one mapping a linear equation, it is true. But it is not true in every type of mapping. Okay? So let us see the next type of mapping. The second type of mapping is many-to-one mapping. And the mapping process is y equals x squared. That means we will be taking x values again. They will be independent values and they will get squared. And the corresponding answers will be the values of y, which will be the members of this range set. Now I have taken negative numbers, positive numbers, zeros as values or members of this domain set, means they will be the values of x. I can take any number, I can take fraction, I can take an irrational number as well, I can take any number, I can take any rational number, any real number can be a member of this domain set. But what about the members of the range set? Any member that you take from the domain set, that will be the x value, which when squared will be giving us a positive number. 0 square will be 0. For every other number, doesn't matter whether it is a negative number or a positive number, when squared will be giving us a positive value. So you see in this range set, you can never have any negative number. So that is what I was saying, that in this case, you can have every real number in the domain set, every real number in the range set. They can be included in either of these two sets. But over here, there is a restriction. You cannot have any negative number in this range set. You can have negative numbers in the domain set, but you cannot have any negative number in the range set. And the name is many-to-one mapping. Many will be referring to the members of the domain set and one will be referring to the members of the range set. Why many? Because negative 2 whole square is positive 4, as well as positive 2 whole square is positive 4. So many values of x or multiple values of x are getting mapped or connected to a one value or a single value of y. Multiple or many members of the domain set are getting connected or mapped to a single member of the range set. Similarly, negative 1 whole square is positive 1, positive 1 whole square is positive 1. Many-to-one mapping. Hence this name. Okay? Third type of mapping. One-to-many mapping. Y is equal to plus minus square root of x. square root of x. So we cannot have any negative number within a square, under a square. And I am not taking complex numbers. I'm only considering the real numbers. Okay. So we cannot have any negative number under a square root. Therefore, you cannot have any negative number in this domain set. So you are seeing that over here there was a restriction for the range set. In this case, there is a restriction for the domain set. You cannot have any negative number as a member of this domain set. You can have 0 or you can have all positive numbers. When x equal to 0, square root of 0 is 0, y equals plus 0 or minus 0, both are the same. So 0 is getting mapped to 0. But when x equal to 1, square root of 1 is 1, y will be equal to either plus 1 or minus 1. So this one member of the domain set is getting mapped to many members of the range set, minus 1 and plus 1. Similarly, when x equal to plus 4, square root of plus 4 is 2. So y will be either plus 2 or minus 2. One member of the domain set is getting connected to many members of the range set. One value of x, many values of y. Therefore, the name one-to-many mapping. The first one will always be referring to the domain set and the second one will be referring to the range set. Okay. Finally, the fourth mapping is many-to-many mapping. Many to many means many values of x mapped to many values of y. It is a bit confusing. So let us take the example. Let us see what is the actual meaning of it. Y equals plus minus square root of 1 minus x squared. When x equal to negative 1 whole square is positive 1, 1 minus 1 is 0, square root of 0 is 0, y will be equal to plus 0 or minus 0, that is simple 0. So negative 1 is getting mapped to this 0. Similarly, positive 1 will also be getting mapped to this 0 because 1 square will be 1. So it is a case of many to one mapping. Many values of x or many members of the domain set are getting mapped to a single member of the range set. When x equal to 0, what happens? 0 square is 0, 1 minus 0 is 1, square root of 1 is 1, y will be equal to plus 1 or minus 1. So one member of the domain set getting mapped to many members of the range set. It is one-to-many mapping. This one is a case of many-to-one mapping. This one is a case of one-to-many mapping. Combined together, it is many-to-many mapping. Okay? And over here, I have taken negative 1, 0, positive 1. That doesn't mean that you can have all negative values and positive values and 0 in the as members of the domain set. No. If you take negative 2, what happens? X equal to negative 2. Negative 2 whole square is positive 4. 1 minus 4 is negative 3. You cannot have a negative number within the square root. Therefore, negative 2 cannot be taken. I have taken negative 1 doesn't mean that you can take negative 1.5, negative 2. Those are not allowed. Even even positive 1.5, positive 2, they are also not allowed. Okay? So there is the restriction for the domain set. We are seeing. Is there any restriction for the range set? This is your task. Find the restriction if at all. If there is any restriction, find the restriction for the range set for this mapping. Okay? So this is many-to-many mapping. And the process you are knowing, the processes are given by these equations. Okay? Now, finally, the one-to-one and the many-to-one mappings are known as functions. The first one and the second one, they are known as functions. The third one and the fourth one, they are not functions. Now, these are all algebraic expressions. But certain algebraic expressions are termed as functions. Not every algebraic expression is a function. What is the criterion for being a function? The criterion is for a single value of x, there should be one and only one value of y. For a single value of x equal to -2, there is only a single value of y, that is 0. For everyone, this, -1 for x equal to -1, y is equal to +1. For x equal to 0, y equal to 2. For a single value of x, you are always having only a single value of y. Hence, it is a function. This is a function expression. This is the condition for being a function. Over here, when x equal to -2, you are having only a single value of y, which is positive. Yes, it is true that +2, when x equal to +2, you are having the same value of y. Doesn't matter. But when x equal to 2, you are having only a single value of y, that is +2. So that is the condition of being a function. If an algebraic expression satisfies this condition, then it will be termed as a function. So these two are functions, but the second last and the last, the third and the fourth, they are not. So students, this brings us to the end of this session. I'm Nilanjana Sanyal and this is my YouTube channel, NS Online Math Classes. Thank you for staying with me till the end. Please like and share this video if you find it useful. Please subscribe to my YouTube channel if you have not subscribed till now. It will be motivating me to make more math videos for you. Bye.